Hi there. I wanted to help you out with some exponent simplification here today. And before we get started, I want to do some of those crazy ones that have lots of negatives and that kind of stuff going on. But I wanted to begin by looking at just the basic rules and making sure you understand what's going on with exponents in general. So if you have some sort of problem like an a cubed times an a squared, you need to look at that like it's an, like it's an a times an a times an a. That's an a cubed right there. But then I'm multiplying it by an a squared, so that's two more of them. So really what you end up with is an a multiplied by itself 5 times. So that's an a to the 5th power. If you'll look at where that comes from, you're really just taking these 3 plus another 2. So we're adding these exponents. Anytime you multiply here, as long as you have a common base, you're just going to add your exponents together because you're just kind of visualizing this, that you have a total of 5 a's there. Okay, if you're dividing, it works kind of similarly. If you write it out, a times a times a times a times a, there's my a to the 5th, over a times a. Okay, so if you had some sort of a fraction like this, what you would typically do is start doing some reducing. This a and this a can reduce, and this a and this a can reduce. So what you really end up with then is an a to the 3rd over 1, or just a to the 3rd. Now usually the way I look at this, you can kind of come over here and see, well, where did that come from? Well, basically I'm just subtracting those exponents. But it gets a little bit weird when we start throwing negative exponents in there and stuff. So I really kind of just look at this and say, well, I always envision this scenario and say, well, if I were to write it all out and started reducing, where would my extras be? Well, since I have more a's here on top, then my extras would end up on top. Sometimes I'll have more on the bottom. In this case, there were more on the top. And then I'm like, well, how many more after you start reducing stuff? Well, that's where that subtraction comes in. I would just subtract those to recognize, well, I'd have 3 extras on top after I reduced. And so that's where that comes from. All right, and then the last one here, we've got an a cubed, so that's a times a times a. But that's being squared, so that means I'm going to take it times itself. So I've got another a times a times a. And if you look at that, what you end up with are 6 a's there. So that's going to be an a to the 6th power. And then come back and see, well, where could have I come up with that without having to write this all out? Because we don't want to have to do that every time. So really all you're doing is you're multiplying those 2 exponents together. So if you have a power that's being raised up to another power, you just multiply exponents together. Okay, so let's look at an example here that kind of ties a lot of those rules together. So what I've got is, I've got some multiplication, I've got some division, I got this power raised up to another power business. All right, so there's different ways that you can do this. The order that you do it doesn't really matter too much, but I guess for me, I like to get rid of those parentheses right off the bat. So here's what I'm going to do. I'm going to go ahead and take everything, because the whole fraction is being squared. So that means every one of these is being raised to the 2nd power. So when you look at this, this is the whole power raised up to another power thing. So if I have an a cubed that I'm going to square, I'm going to multiply those exponents, and I'll end up with an a to the 6th power. And then my b is squared, so multiply powers, and I get a 4. On the bottom, we assume these exponents are 1s, and so when you multiply the powers, you'll end up with an a squared, and then a b squared. And by doing that, I've taken care of this squared, and I've put it on everything on top and everything on bottom, so I can be done with my parentheses. So then your next step is to do any reducing that you can. Okay, so when I look at this, let's look at a's first of all. And so I go back to that. Well, I've got 6 of them on top, and I've got 2 of them on the bottom. So if I were to line them all up, I'd have more of them on top, so I'd end up with extras on the top. And then I do that subtraction to think of how many. So 6 minus 2, I'd have 4. That'd be reduced to an a to the 4th. Now let's try it with the b's. I've got 4 of them on top, 2 of them on the bottom, so if I were to list them all out, I'd have 2 extra on the top. And at that point, I don't have anything on the bottom, so there's no sense of even writing it as a fraction. There's my answer. Okay, so now I'm going to try some that have some negative exponents, as you can see in this example. However, before I jump into that, let's just backtrack a minute and look at a situation like if I had an x to the third over, let's say, an x to the fifth. Well, there's 2 ways to look at that. You can look at that and say, well, I'd have 3 x's on top, I'd have 5 on the bottom. When I start reducing, I'd have 2 extra on the bottom. So it would look like a 1 over x squared. Okay, the other way to look at that problem is to do the subtraction, where I take the exponent here and subtract that exponent. The problem is, if I take 3 and subtract 5, I actually get a negative 2. Well, both of those are correct answers. So I guess what I need you to recognize then is when you take something to a negative power, what that really means is it's supposed to be shifted to the denominator. So those are the same thing. An x to the negative second is equivalent to a 1 over x squared. So what we're going to do, as soon as we see something has a negative exponent, we're going to shift it down to the denominator. Now, once you put it in the denominator, notice that the exponent on it is now positive. So in that shifting process, you lose that negative. Okay, so another thing that might happen here is that negative exponent might end up being on a term that's already in the denominator. If that's the case, then you're just shifting it back up to the top. So a negative exponent kind of means it's in the wrong place. So that negative 2 exponent on that term, I'm going to bump it up, and now it's going to become an x squared. I could put it over 1, but we usually don't bother doing that unless we have something else down there other than 1. So that would be how we'd handle a negative exponent in the denominator. So these 2 things, keep that in mind. Negative exponents means it's in the wrong place. Okay, so let's jump over here and try this example then. I've got a negative 4. Now that is not a negative exponent, it's just a negative number, so don't get that confused with the idea of having a negative exponent. It's just a negative 4. But this x right here is to the negative second, so it's going to end up having to go down to the denominator. This y is fine, and when I look at the bottom, this y has a negative exponent, so it's going to come up. Okay, so let's rewrite all of this. My negative 4 is just going to stay put. And then the x to the negative second is going to go down, but when I move it down, it's now going to be positive. And then the y just stays where it's at. Now let's look at the denominator. This x stays put, but this y squared is going to have to go up. So the x stays put, and the y squared goes up. Okay, now let's combine those things because you have a negative 4. I've got a y times a y squared, that's just a y cubed. And on the bottom I have an x squared times an x, that's an x cubed. And so that's what we've got, simplified. Okay, now futuristically, I wouldn't necessarily have to write this step every time. It's kind of what you're used to or what you're familiar with or what you like to do as far as how much work you might show. I might just look at that and say, oh, these 2 are in the wrong place. They need to go down. There's already 1 there, so I'm going to end up with 3 of them lined up there and jump right to that stage. Or I might say on my y's, oh, these 2 are in the wrong place. They have to go up and join the one that's already there, so I'll end up with 3 of them up there. You do what you need to do. Okay, so let's just practice a couple more of these types of problems. So on this one, everything in the fraction is being taken to the negative second power. So I'm going to write that as a 3 to the negative second, x to the negative second. And on the bottom, I'm going to have a y. Remember, power raised to a power, I have to multiply. So that's going to be a negative 10. All right, so absolutely everything has a negative exponent on it. So everything is going to have to move. So these two are going to end up going down. This one's going to end up going up. So then I'm going to have a 3 squared. I'm sorry, let me undo that. Let's just move the y up top first. So the y to the 10th will be on the top, and then the 3 squared and the x squared would be on the bottom. Now remember, when you move it, that's how you get rid of the negative exponents. The only thing I would do at the end here is go ahead and write what 3 squared is. So this would become y to the 10th over 9x squared. And that would be my final answer on that. Notice that the negative exponents have nothing to do with the sign, nothing turned negative. I have no negative numbers here. The negative exponents just move the location. Okay, so let's try this other one. Got a lot of stuff going on in this one. But what I want you to notice here is that it's not like the entire fraction being taken to some power. It's the numerator doing something and then the denominator doing something different. So let's just write it out. I'm going to have a 6 to the negative second. An m, multiply those powers, so that'll be a negative 6. And an n, a negative 1 times a negative 2, actually gets me a positive 2. So that actually helped get rid of my negative 1 exponent. All right, let's try it on the bottom. You'll have 4 to the negative third. M is going to end up to the positive third, and n is currently to the first power, but multiply that, it's going to end up to the negative third. Okay. So I'm going to go ahead and show the steps of the work. If you can do a little bit of it in your head, that's okay too. But I'm going to sit here and just start taking everything that's in the numerator and dealing with it. So I have a 6 to the negative second. That's got to go down. Oops. Once I move it, it's not negative anymore. So it's just going to be a 6 squared. Okay, the m to the negative 6 has to go down. So now it's an m to the 6th on the bottom. The n squared is fine where it's at. Now let's look at our denominator and shift anything that has a negative exponent. So this and this will have to go up. So I'm going to end up with a 4 cubed. I like to put my numbers in front, so I'm going to put that 4 cubed in front. The m cubed can stay where it's at, and the n to the negative third is going to bump up. So now I have managed to get rid of all of my exponents. So now let's just simplify. So a 4 cubed, 4 times 4 times 4, that's a 64. And then I have an n squared times an n cubed. Just add those all up, I end up with 5 n's up on top. On the bottom, I have a 6 squared, that's 36. And an m to the 6th times an m to the 3rd should get me an m to the 9th. Okay, last step would go ahead and simplify the number part of this. 4 would go into both of those. So 4 goes into 64 16 times. So it'll be a 16 into the 5th. And 4 goes into 36 9 times. So it'll be a 9m to the 9th. And that's our simplified exponent. All right, here's our last one. I just am trying to do a sampling of different types that you're going to see on your homework there. And so what was different about this one is you have this negative 4 out in front. Notice that it's outside the parentheses. So that negative 4 is not going to get raised to this power, but everything inside the parentheses would. So I'm going to have my negative 4. It's going to get multiplied by a 3 to the negative second. A, remember, multiplying powers, and a b to the negative 10. Okay, now let's move anything that has a negative exponent. Now it's not a fraction right now, but by moving it, we're going to turn it into a fraction. Now this negative 4 is just a negative number. It doesn't shift. So it's just a negative 4 on top. But the 3 to the negative second, now that's a negative exponent. So that 3 squared is going to go down. The a to the 4th gets to stay put, but the b to the negative 10th is going to shift down. And when I shift, I'm going to get rid of the negatives. All right, looks like there's not going to be anything I can reduce with my variables because I just have each one of them there once. This is really just going to be a 9, but that's not going to reduce with a 4. So I think just my final answer will be a negative 4 a to the 4th over a 9 b to the 10th. All right, I hope this helps.